Section 1.4, absolute value equations. First thing to note is the absolute value of a number is a number's distance from zero. So when we have an equation, like the one on the screen, absolute value of x equals 10, we want to find what are the values that x can take on that are 10 away from zero. So for these types of problems, we always want to split our equation up into two parts. Okay, and in this case, there's obviously two things that x can take on that are 10 away from 0. 10 obviously is 1, okay, and negative 10, because both those numbers are 10 away from 0. But now let's say we had something that's a little more complex on the inside. Okay, we have x minus 4 inside the absolute value sign equals 3. So just like before, we're going to split this up into two parts. Okay, and we want to write two different equations. Okay, now whatever's on the inside, we write twice, x minus 4, x minus 4. Now we want this to equal 3, which means we want it to be 3 away from 0. Okay, 3 is 3 away from 0, and negative 3 is 3 away from 0. So those are the two equations that we set those things equal to. And then we're just going to solve them out. So add 4 to both sides, and solve. Okay, so in one case we get x equals 7, and the other one we get x equals 1. If we were to plug either of those back into our answer, 7 minus 4, take the absolute value equals 3. If we were to plug in a 1, 1 minus 4 is negative 3, but the absolute value of negative 3 equals 3. So let's give this one a try. So we write our two equations. 2x plus 6 equals positive and negative 14 and negative 14. So this gets written twice. Okay, it's 14 away from 0, so one gets a positive, one gets a negative. And then we're just going to solve it out. So minus 6. Okay, and we can solve these both at once. So in one case we get 2x equals 8. On the other we get 2x equals negative 20. Divide them by 2, and we get our answers. X equals 4, x equals negative 10. Again, if we plug it in, so plug in a 4, we get 14, absolute value of 14 equals 14. Plug in a negative 10, and we get absolute value of negative 14 also equals 14. All right, slightly advanced problem is when we have x's on both sides. Okay, we don't do this any differently than the other problems. So we start off by writing our two equations. Okay, and just like our other ones, we take whatever's on the right. One gets a positive, the other gets a negative. Okay, and we solve these out algebraically. So all the x's are going to move to one side, and then solve. Okay, so we get our two answers. Now, one additional step when we have x's on both sides is we have to check our answers. It's required. Okay, on the previous two, that was really just to see if we had done it right. But in this case, we might have something called an extraneous solution, where it looks like we have a right answer, but we don't actually have a right answer. So when we plug these in, okay, let's start with a 9. Okay, so we plug it into the left side, 2 times 9 plus 18, we get 36. Now that's inside absolute value. Absolute value of 36, does it equal what we get into the right? 4 times 9, also 36. That looks good. All right, when we do the negative 3, 2 times negative 3, that's negative 6, plus 18, that's 12. Absolute value of 12, does it equal what we get on the right? Well, on the right, we have 4 times negative 3, which is negative 12. Okay, that's not correct. All right, this is called an extraneous solution. It's not that we've done anything wrong. It's just that when we plug this in, it's not actually a solution to this problem. That's why we always have to check when we have x's on both sides. All right, last problem here. Okay, we can see there's a couple extra steps here. Before we split it up into two parts, we need to get this absolute value all by itself. So let's subtract the 7. Actually, before I write this out, think of that box, that absolute value of 3x plus 5, as its own variable. So if this were like a 2y plus 7 equals 3. Okay, first thing we would do is subtract the 7, then we would divide by 2. Those are the steps that I'm taking to get that absolute value of 3x plus 5 by itself. So I'm getting rid of the 7 first, then the 2. All right, so I subtract the 7. Okay, at this point I have 2 times the absolute value equals -4. Okay, next I want to divide by 2. Okay, and I have this. Now, one thing that we always want to keep in mind about absolute value is that this is always positive. Okay, so if we get to a point like this, absolute value of 3x plus 5 equals -2, we're going to stop. Okay, this is not possible. We can't get an absolute value equaling a -2. Right? When we do these two equations and we set it equal to -2, we're just saying that the inside would equal to -2. Okay, it's not possible to take the absolute value and get a negative number. All right, so the answer to this is no solution. Okay, it's not possible to take the absolute value and get a negative number.